Welcome also from my side to this webinar, The Rise of Platform Engineering from Tool Stack to Capabilities. A quick introduction to Giant Swarm, what we are doing. So everything we do is basically based on the opinion or the belief that every platform team shouldn't feel the pain of day-to-day operations while trying to enable the developers. So our mission is that we empower platform teams to drive business success by establishing their pivotal role as developer enablers. Our offering is based on 3 pillars like technology, operations, people, and processes. We provide an opinionated platform for what we believe makes you successful. We also carry the pager for you so you can sleep tight at night 24/7. And also do the whole lifecycle management of all the tooling around this platform. And on top of that, we want to be a trusted advisor in your cloud native journey so that you can, as a team, unleash your potential, meaning that we work closely with you, trying to share the knowledge we gained over the last years so you can benefit from this knowledge and can be prepared for your cloud native journey in the future. A little bit to my person. My name is Philippe Tiede. I'm now for 1 year a sales engineer at Giant Swarm. My job is actually to bridge the gap between sales and product, meaning that I'm trying to, or that I'm giving in the sales process, having the more technical perspective to explain our product better to prospects and potential customers, and also bring new demands, views from the customers to products so that we can work closely with this to build a better product in the future. I started actually as a consultant for DevOps transformation, and my main focus was more on the organizational side and more agile methods. So I have been studying economics, IT systems, which is a combination actually from a business perspective and IT perspective. So I always try to see the system as a whole, and I'm not that technical deep dive than an engineer should be or can be. So I'm more on the high level trying to get both sides together. So this is also what you can expect from today's webinar. I will talk a bit about current challenges in platform engineering we have. I hopefully provide you a new perspective of platform engineering so that you can have a little mindset shift here in the future with platform engineering, what you're doing in your company. What I'm not talking about is a technical deep dive, so you won't see a lot of tools or how to build up tools, and also you won't see a blueprint on how to perform perfectly on platform engineering, because my opinion is that every journey is quite unique, and every company, every team has to find their own way to approach platform engineering in the future. So what we're talking today, or what we're talking about today, is I will give you a little introduction where I talk about the motivation, why platform engineering is important, what do we want to achieve, what are challenges for developers, and what are challenges for platform engineers. Then I will talk a little bit about the platform vision, what is the goal, what is the overall setup, and what is the future operating model. Then I will talk about how we transition from tools to capabilities, what needs to be done. And then I will give you some key takeaways, what I think you should take away from this webinar today. And I will give you a little pitch about Giant Swarm and how to engage with Giant Swarm in the end, because at the end, I'm still a salesperson here. Okay, so when thinking about platform engineering, thinking about IT, and all we do, everything we do, I think it's best to have a bigger picture here. So normally we have the business perspective, the developer perspective, and the operations perspective in all companies. The business perspective always focus on, okay, how can we introduce new products to the market? How can we improve our products at the market? How can we mainly have digital products, getting new revenue, and everything the business is trying to do is being faster with products, this is why we have all these methods like build, measure, learn or lean startup methods, so that we can increase our feedback loops from the customer to business in order to increase our revenue. To support this, we have our developers. They mainly try to support the business by providing features, by providing software faster, in a better quality and more often, and they feel the direct pressure from the business. So this is why we have methods like DevOps, for example, or Scrum, which improves us or enables us to deliver software faster. And then obviously we have operations that support the developers by providing a sustainable, maintainable, and reliable infrastructure so the developer can reach their goals in order to support the business in the end. So everything we do in IT, and I think that still holds for everything we do, is that we want to deliver products faster, more often, with better quality, and more efficiently than before. Therefore, especially on an operations perspective, we have to focus on developer productivity, because the more the developers are productive, the more we can increase our main goal, shipping products faster. This should also be more efficient in the ways we provide cloud infrastructure in the future. So this is the main goal we have, I think, in everything we do in IT. So what is the problem right now for developers? So we had a rise in the past with cloud native, obviously with cloud computing, and developers, especially developer teams, new developer teams and new product needs, they had all of a sudden an opportunity to start their own cloud native journey, because all they need is, or they needed is, the credit card actually. So they could start running a VM just by paying it with the credit card they provided from business, for example, from the business stakeholder, and haven't been relying on the infrastructure side anymore in the sense of speed. So we saw a lot of, I would say, side IT within the companies, that every team built their own stuff, their own CI/CD pipelines, for example, their own environments, and so on and so forth. And haven't spoken to the IT department anymore because of speed. The pressure they feel from business, now they can provide it with cloud native. This brings us with a lot of issues actually, because this shift left of IT infrastructure tasks actually provided or comes with a lot of challenges. I call it the curse of shift left, because now all of a sudden we have cognitive overload from the developer side. We have like maintaining all the stuff, lifecycle management of the infrastructure. We have also cultural challenges within the companies. Are we allowed to use cloud native in the company or not? And a lot of burden has got on the shoulders from the developers. And we also have like a lot of inefficiencies, because now we have like 100 teams building 100 solutions for actually the same problem. For example, the CI/CD pipeline. Now of the sudden we have like 100 different CI/CD pipelines. So those inefficiencies and this cognitive overload actually hinders our developers to be productive anymore. So they are busy keeping things running at the end. What we want to achieve is that they have more space to create value and innovate and learn, meaning that we want to reduce the infrastructure tasks and the knowledge they have, so they can more focus on their domain, they can more focus on software engineering, and they can more focus on self-development. So this is the origin of platform engineering in my perspective, but platform engineering obviously helps us to provide infrastructure in a faster way, more efficient than before, and we try to abstract away the infrastructure for the developers so they don't have or they don't need to have this deeper infrastructure knowledge anymore, and also not having the daily tasks about maintaining, for example, the infrastructure they had built. So this is the goal of platform engineering, obviously. So saying, okay, we want to reduce the cognitive overload for developers on the infrastructure side. And in the ideal world, And this is why, or what we see a lot with platform engineering teams when we talk to them, is like an ideal world. Obviously, we have like unlimited resources. We have like, I don't know, 50 engineers we can provide, we can build the platform with. We have endless time. We have, I don't know, we can take our time like 3 years to build this platform, and the scope is fixed. Like we have a set of stuff we have to do. This would be the ideal world. Unfortunately, what we see a lot is like, okay, that we have limited resources, like for example, in cloud native environment, and especially in Kubernetes, for example, we don't have the knowledge, right? We can buy the knowledge just as we please, because it's not at the market right now. And also we have a lot of time pressure, which I mentioned before. Business is pressuring developers, and they need capabilities right now, right away, and they cannot wait 3 years, for example, for you to build up the platform. And we have unlimited scope. So we always have new requirements. We always have new use cases we have to provide. We also have different maturities of developers that might have different needs. So we have an endless scope, actually, which makes it really hard for platform engineers to come up with the right platform. And one symptom of this is always like the growing backlog symptom, that you always have the feeling that your pace behind, and there's requirements after requirements, or sometimes they're not defined well, and you actually have to figure out what a developer team actually wants to use, or what they actually need. So this is the whole challenge part. From the developer side, we have cognitive overload, and from the platform engineering side, we have too much to do for the resources we have and the limited time we have. So what is the platform vision? Obviously, it's to enable our developers and provide efficient or infrastructure services in an efficient way. And what we see a lot is when platform engineers starting their platform journey, they all think first about, okay, all the tools we actually need. We need a service mesh, we need Loki, do we need Loki or Elk, whatever. We need a car solution, we need GitOps, whatever. And they think about all the tools that are in the cloud native environment, and they try to figure out how to build this, and then they build it, and at the end they have a beautiful, nice platform, but actually the developers cannot use it, or aren't using it, because at the meantime they had built something else, for example, found some workarounds, and or maybe at the time we have provided these features, they are not embedded, or they are not state of the art anymore. Those are main problems, and we see, like, for example, backlogs or roadmaps, they are all tool-based, actually. But the problem, or the mindset shift here is, from my perspective, is we have to think about what the developer actually wants to achieve. So what the developer actually wants to achieve is from getting A to B. That might be having code that the developer wants to commit and getting into production and have it released, for example, in A/B testing or in canary release or whatever. Or they want to see, okay, if my software, if I wrote code and want to deploy it into production, what vulnerabilities do we have there? So they want to achieve things. They want feedback fast, and they want to get from A to B in a nice way, I would say. So when you think about platform engineering, you should always think about the right picture. Having a car, this is what a developer actually wants. And also this means when a developer wants to get from A to B, maybe you as a platform engineer in the future should think about, okay, are there other ways they need to, or they can achieve their goals? Maybe a plane is better, maybe a train is better to get there faster or more convenient. So be more advisory to your developers at the end by achieving those goals. So for me, what is platform engineering, or what is the platform? For me, everything that you have, obviously you have to focus is like the use cases you have here above, like the IT, retail, AI, machine learning, finance use cases, the different teams. they want to have value or added value, and they have value streams. And along this value stream, you should provide a set of capabilities. Obviously, those can be embedded in self-services, for example, having a deployment button. The developer just can click, and then he has an ongoing deployment path there, or getting a developer environment via self-services. All those things are embedded in self-services. But for me, it's also important to understand that platform engineering in the future will also mean that you have to think more about advisory and more about support. And I mean, obviously, support is based on 24/7. It's based on if I have an incident, how can I fix it? But it's also like when a customer or a developer wants to onboard their application, how can we advise them to do it right? How can we provide best practices, for example, in the way they want to implement their architecture or their software? So those are all things that might be there in the future, should be there in the future, instead of just implementing self-services. So not only focusing about the self-services, obviously you can automate this, what you have in the advisory, for example, more into the self-services to get more manual work done automatically. But for me, the blue thingy, that's your platform here. And everything underneath that has to be abstracted away completely. So because we don't have a competitive advantage here. So for platform engineering, I have like 3 principles, like move up the stack, try to find solutions how we can abstract away more and more of our cloud native functionality. Let the interface let it be driven by the users, for example, so that they can decide what is best for them right now, and work closely with them how to define these interfaces so you have a better understanding and a better value for developers in the end. And also think about your platform as an internal marketplace. You share not only one team, but a bunch of teams, and also try to think about what can a developer team, or maybe can a developer team, a more mature one, can provide also self-services to other developer teams with your platform at the end, so that you have an open marketplace there at the end, and you can always adapt and extend your platform in the end. So I mentioned the platform model, and I mentioned that you have to work more closely together. For me, it's summarized in this picture. We have on the one side the product teams that obviously have to build and run delightful products and serve the customers and drive revenue. They provide feedback, input about identified common opportunities they have in the developer department or in the developer area. And you have the task now to adopt those feedback and build best practices for this, and also provide guidelines for the developers in order to use the platform the best way. And obviously you have to build and run a tech platform that reduces the complexity and you drives organizational productivity in the end. This is for me really important, because when we talk to platform engineering teams, not all of them talk to the developers on a regular basis, like having shared meetings, for example, or shared processes. I think in the future, this should be more common, that we have more combined processes and meetings here with our developers to identify how and what exactly the developer needs. A lot of talking was done in the community about, okay, is platform engineering the next DevOps? Is DevOps dead right now? For me, I think platform engineering is just a more efficient way to do DevOps. When you remember it in the beginning, I was talking about the main goal we always have. I think DevOps and platform engineering both try to solve the same problem. The difference is that we now see that, okay, based on the cognitive overload we provided or we have right now with our developers, platform engineering might be a more efficient and way faster way to solve the main goal. And I try to structure the next slides with the CALMS framework from DevOps, because I think that's really nice approach here, because it's not only focusing on technology, but also cultural aspects, process aspects. And CALMS actually stands for culture, automation, lean, measurement, and sharing. And I think those 5 letters can also be implemented in platform engineering, or can be a framework for platform engineering as well, saying that everybody or every team can think about what should we actually do in those 5 letters, in those 5 sections, to provide better services or better methodologically for our developers here. Starting for example with platform thinking, which in my perspective is a solely cultural aspect. You should keep in mind, or at least this is something might be changing in the future, is platform engineering. It's not about building a tech stack anymore, a shiny tech stack anymore, which I talked about before. It's more about building a product, and this includes also product management and design. So what you have as a team, platform engineering team, you might have product management tasks or methods more in your team in the future, maybe, in order to have a more product mindset here. Also, the platform engineering or platform engineering shifts the role of an engineer towards a developer enabler. This means that at the end, we are not working like 100% on tool stack anymore, but we have more like 30% working with our developers and 70%, for example, building the tech stack. So this is something a lot of, or one of the biggest mindset change or changes with platform engineering, my perspective, that we have a shift in the role actually. Then platform engineering is obviously not about the technology. I think technology obviously is important in our environment, but I think that it's only the second question. The first question should be, what human problems do we try to solve here? So especially developers, when they deal with centralized platforms, they feel a lot of blockers based, for example, based on policies and restrictions, and they feel blocked a lot, and they try to find out workarounds. I think that when we talk more with our developers, try to find out why they do the workarounds, how they do the workarounds, and try to find out how we can solve this together. I think this is the first approach to platform engineering, and then we can think about how can we embed this in technology. And obviously, this is also something I mentioned before, is like platform engineering is about collaboration and leads to joint processes with the developers. Yeah, I mentioned the tasks. The horizon of what to achieve with the platform team extends. It's not only by building like a CAS product, monitoring observability, all this tooling around the Kubernetes cluster, for example, anymore. It's more. It's defines a long strategy, design, advisory, adoption, and this is just an example. This can be used to get started, but I think every platform team should think about, okay, what is my journey? What is the value stream I have in my team, and how can I embed those tasks? For example, how can I define my product ownership within the company? What is my product? How can I get funding from a management, for example, for my product? What is my platform strategy? Do I want to do multi-cloud? Do I want to use single cloud? All the things you have as a strategy, obviously you do it at some level, but for me, for example, the strategy part always has to get along with your developers in the future. And also like designing, having value stream management more often to figure out what are the main blockers right now in the value streams the developer have, and so on and so forth. Also, for example, in advisory, how can I train my developers to use my platform in the future? How can I marketing it so that other developers feel the need to use my platform in the future, and so on and so forth. I think those extends the platform engineering role and the traditional operations with a lot of new aspects in the future. I mentioned value streams, and give me a second. For me, it's really important that we also, as a platform team, think more in value streams. So what is the value stream our developers have? And obviously, when we talk about developers and they want to ship products faster, more often in a better quality, then we have to think about the DevOps cycle, obviously. So we have from plan, code, build to operate, monitor. We have everything here. That's the main value stream, in my opinion. Obviously, this value stream can be divided in different sub-value streams, and this can help us to define a walking skeleton. So what is my developer actually needs to achieve in order to get from A to B. Imagine the car again, that we have here different steps. What are the steps and how can we provide value here? And obviously, we have to continuously improve along the value stream. This means at the first instance, the capability you provide for your developers can be a single process. For example, you're scanning your CVEs for the developers and then you talk to them in a shared process, in a shared meeting. Okay, those are the CVEs. In our opinion, those are the most important ones. You have to fix now. You have to embed them in your next sprint. Otherwise, we have a big issue here. Obviously, in the future, this can also be provided as a self-service or an automated process so that the developer has this capabilities right away, those vulnerabilities right away in their backlog, for example, with the right priorities, with the right information they need. So they can, they're not depending on you again, and you don't have the handovers, which makes a process also inefficient in the long run. But talking about the walking skeleton, I think when you build up your roadmap and you build up your user stories, I see a lot user stories having, as a developer, I want to use Grafana. I don't know. This is not a user story for me. For me, it's okay. I want to have insights about my application. I want to see how my application is performing, so I can improve myself in the future. And I think when you build up your roadmap and your use cases or user stories, they end up in your backlog. You always have to think about the steps getting from A to B. For example, here we have commit code and continuous delivery. You have the several steps in yellow, and those steps, you don't make them up. Obviously, some people know what a developer is doing, but obviously this has to be done with your developers hand in hand. They have to say, okay, what are the steps? What are my needs here right now, and what they need in sense of usability. Then obviously you can define, okay, what needs to be done, or what features can be used, or what capabilities can be provided within those steps. And then you can obviously build releases. And I think that's really nice because when we think about the different approach, like having a tool stack and thinking, okay, now I need Elk, now I need service mesh, for example, now I have policy enforcement, whatever. They interact at some point, and they interact in the end that we want to provide a capability. For example, service mesh touches so many things like your security, your networking, and also observability, that it's really hard to just focus on the single areas and then try to figure out what the capability is. Think about the capability first, and then think about how can we as a team provide these capabilities, and what do we need to touch here? Do we need to touch security, and so on and so forth? This also improves the interaction with you within the team, obviously, because you work more cross-functional on different areas and different capabilities. There's a question, what is the difference between feature and capability? This is a really good question because most of the times people use it as a synonym. for me, a feature is something your platform provides, for example, like a Git repository, GitOps as a feature. And I think the capability at the end is what the developer is, or how the developer is using GitOps, for example, in the end, in order to achieve something, for example, having a release pipeline, having A/B testing. So for me, this is the capability, and the feature is, for example, having a GitOps approach in your platform. So this one is a highly discussed topic, I think, and we see a trend here that a lot of platform engineers or engineering teams move step by step towards managed services, and I think that's the right approach in the end, because one thing is that you as a platform team shouldn't reinvent the wheel anymore. This means when we have developer enablement in the amount we had seen on this big slide with all the steps and all the tasks you will have in the future, I think it's a lot on top of your day two operations. So I see a lot of teams struggling between developer enablement, what they actually want to achieve, and day two operations where they're stuck to, and running from issue to issue, having a lot of planned tasks they cannot provide or cannot solve because we have a lot of unplanned tasks in the long run. And I think this is something you have to focus on. The main goal is still the developer enablement, and day two operations is something you need to do, but the more you can abstract for yourself also away, the less day two operations you have on the long run, hopefully. Also, one thing is you lose money as a company and you lose energy as a platform engineering team when you not provide the needed capabilities right now for developers. I will show an example right after that. And also the requirements, as mentioned before in the intro, grow faster than capabilities can be delivered. That's by nature, because we have a much higher pace in development, in the development area, in software development, than we have in our ecosystem for Kubernetes. I was talking about, okay, you lose money when you don't provide your capabilities right now. And I brought a little use case here, which is, in my opinion, not that far away from reality. I think those are typical numbers we see a lot in for internal developer platforms doing platform engineering. And I have some assumptions. When you want to calculate them with your own numbers, you can just put it in, but I think those are typical numbers, I would say. And we have, like, for example, current revenue in our online shop, for example, which is $16 million US per year. We build a platform right now, or thinking about building a platform right now, and we are thinking, okay, this development time will be 2 years. We estimate total cost from $2.6 billion US, and we calculate ongoing OPEX in the future from $750,000 a year, and we estimate the productivity gain from 700 hours. This productivity gain is based on the tools the developer don't have to manage by themselves in the future, so they can be more productive on the software development side. So this is the productivity gain here. In US dollar, this means $2.8 million a year, which is a productivity increase of 17.5%. And what I want to show you is now, obviously, when we start the journey, or we are in the middle of the journey, we think, okay, now we have our revenue, which is in blue, on day 0 or year 0, and we have our opportunity cost, which is the lost productivity or the productivity losses we have right now. Meaning, if we have all the capabilities with our platform right now, we could use, or we could increase our revenue by the opportunity cost. So this is the idea behind it. And our expectation is obviously that the opportunity cost decreases over time, because over time we enable or we provide more capabilities over time. Problem is, or at the end, the opportunity cost calculates like 8.54 million US dollar, which is when you look before the estimated productivity gain over the years, and obviously minus the capabilities we deliver over time. The payback period here is like 5.79 years. So after that, the platform is reinvested. So this, you can just put the numbers in and calculate by yourself if you want to, but those are the numbers we have right now. So this is the expectation. The problem is obviously that, or the reality, and I told you this with the two triangles, is that the requirements grow faster than capabilities can be delivered. This can be because of obvious reasons, like we have more teams we have to support right now. We have different use cases because business thinks about new ways to gain revenue and so on and so forth. So we see, okay, the opportunity cost increase over time, and we have additional op costs, and we always run behind as an internal platform team. So this is the growing backlogs symptom. This is always the running behind symptom. And this is always like, okay, why do we burn money at the end? So those are the symptoms when you talk to managers, platform engineers. This is something they feel, this is something they see, and this is the explanation for it. I didn't include other cost factors, for example, the onboarding time of your platform team, or the onboarding of new team members, which also might take a lot of time in order to be productive as a platform team. I didn't calculate it in the cost of delay, which come up or which occur when you're missing a capability and therefore the developer cannot provide the service or a product to business, and then we cannot gain revenue from it. So meaning, okay, we are just too late at the party, and so on and so forth. So there are a lot of cost factors also within this journey, which prohibits you to keep up or solving all the capabilities problems you have on the long run. So, and this is now leading to a make or buy decision, obviously. So thinking about what is the current trend, a lot of people trying to use managed service or to accelerate their platform engineering. For example, AKS, EKS. While AKS, EKS obviously solves a really specific problem, like providing your Kubernetes clusters, it does not provide so much value to your product, because in the end, you still have to build a platform around it. You still have to build around security, monitoring. You have to figure out the connectivity within your local network in your company, for example. And this solves the problem. Obviously, it does add a little bit to your product, because now you can deliver, for example, Kubernetes clusters faster than before, but it does not provide that much value to your developers in the end. On the other hand, the internal developer platform does add a lot of value to your developers. I mentioned before, you have connectivity, overload, which you can decrease. You can gain productivity, and you also can gain 5 times more revenue for your business in the end using an internal developer platform. So this has a lot of value added to your product. The problem is that this does not give you a competitive advantage for your company. So building a Kubernetes cluster, building a monitoring around it, building security around it, this is, in my opinion, commodity, and a lot of people have solved this problem before. So it is not competitive enough anymore to be built completely, entirely in your company anymore. So when you have like this make or buy matrix, and this is what studies and the theory explains us you have to outsource this completely. But from my perspective, and also obviously from the perspective of GiantSwarm, you have to purchase this with a long-term partnership. It doesn't help you that you have, like, for example, an OpenShift, and then you have to still figure out how to configure it and how to make the best use of it. I think you need a long-term partner that helps you to configure all the stuff on the long run, and also brings all the commodity work out of the box with you, so you can mainly focus on how can I, for example, use this platform in order to create more value for my IoT use cases, for my web shop or whatever. So Kubernetes is not your core business anymore, unfortunately. Also, when you think about building a product, the product is not your Kubernetes platform. The product is your internal developer platform and the added value you provide for your developers. Then the last, I think it's the last one, is measure your product, meaning you have to include more product management KPIs into your measurement system. I know a lot of platform teams have like the basic infrastructure measurements, like your usage, your CPU, RAM, how many clusters, how many containers, whatever, see when the memory is overrunning. But when you think about the product and when you think about your internal developer platform as a product, you also should think about a new measurement system or additional measurements you have to keep in mind. Also for validation purposes, like, okay, how is my developer using my platform in order to improve my service offering here for my developers? So meaning, okay, traditionally we have the operations numbers I already mentioned. Then we have the product management numbers, like, okay, what is the customer lifetime value? How is the customer acquisition costs actually? So how much does it cost me or the customer to get onboarded on my platform? This can be money, this can be time, this can be new requirements that occur. And when you have like the situation that every new developer team leads to 5, 10, 7 new requirements, you should think about ways to have a better idea on how to provide those requirements. Obviously, the active users of your platform and so on and so forth. So those are the product management KPIs, and on the right side, the developer enablement KPIs are the traditional DORA metrics, like what is the lead time from my developers to get code committed from commit to production? What is the deployment frequency? Can they deploy more often, more independently? What is the change failure rate while deploying stuff? And what is the availability? And what is the mean time to restore a service, actually, like the end service? So those are the metrics you also should include in order to verify if your platform is enabling a developer or not, sorry. And yeah, obviously metrics like usability and adoptability are also metrics, because in the end, what you try to achieve is having a platform a lot of developers can use, and not a platform which is nice and shiny, but nobody uses it. So in the end, my key takeaways are that you should think more in capabilities instead of tools, that you are not operations anymore, so your tasks will shift and you will have additional tasks in the future, and that the added value of the platform is obviously determined by the use or by its use of the developers. And the last one is you can no longer do everything at once. You should think about ways not only to move up the stack for your developers, but also think about ways where you can move up the stack. Okay. This is it from my side. A little pitch here before I go to questions is obviously if you're at the journey right now, you started your journey or you're already in your journey, and you feel like, okay, I don't have enough resources, my backlog is growing, my developer is complaining all the time, I have time pressure, what so on and so forth, please talk to us. We are happy to help here and try to accelerate and boost your developer, your platform engineering, and find ways to best enable your developers. What we usually do, and this is where you can talk to me directly, is like having a demo, for example, if you want to see or want to understand our product a bit better, or maybe you want to have an assessment where you say, okay, maybe I don't need direct help right now, but I have the feeling we have some issues, and you want a second opinion on it. We are happy doing an assessment, and obviously we also are happy to do POCs and help you to your way to production, or also to improve your production workloads and your platform here in the end. Yeah,